Let's solve some MCQs from arithmetic progression. So the first question is asking which of the following is or are an arithmetic progression. They have given us three number series and we have to identify which is an AP. So a number series can have any pattern, it can follow any rule, but an AP is a very specific type of a number series. And for a series to be called an AP, I need to check whether the consecutive terms in that series have a common difference. Like if I take the second number minus the first number, is that same as the third number minus the second number? And is that also same as the fourth number minus the third number? So I have to check whether the consecutive terms have a common difference. If they do, then that is an AP. If they don't, then that is not an AP. It will be some other kind of a pattern or some other kind of series. So if I check the first number series, which is 1, 4, 9 and 16, uh, if I check the second number minus the first number, 4 minus 1 is 3. If I check the third number and the second number, 9 minus 4 is 5. And the fourth number minus the third number, 16 minus 9, is actually 7. So I can see that the difference between these numbers are actually getting larger. It's increasing. So I can say that the first series is not an AP, because for an AP I wanted the same difference between all the consecutive numbers. So 1, 4, 9 and 16 are actually square numbers, perfect squares, but it's not an AP. Okay. Then the second number series is root 3, 2 root 3, 3 root 3 and 4 root 3. So if I again check the second number minus the first number, 2 root 3 minus root 3 is root 3. Then the third number minus the second number, 3 root 3 minus 2 root 3 is again root 3. And if I check 4 root 3 minus 3 root 3, it's again root 3. So I can say that the numbers in this series have a common difference. So therefore, the second series is definitely an AP. Now let's look at the third series, 8, 6, 4 and 2. So the numbers are getting smaller here. So if I look at the second number minus the first number, 6 minus 8 is minus 2. Then 4 minus 6 is again minus 2. And 2 minus 4 is again minus 2. So I can say that the common difference here is minus 2. It's negative. But I can still say that the third series is also an AP. So now if I look at the options, option C is correct. That only the second and the third series are AP. The first one is not an AP. Alright. Now let's look at the next question. This was part of 2022 where in this format of the MCQ, the 4 subparts are all related. They are parts of the same question. This format is not there currently. Okay, so the question is the nth term of an AP is 3n plus 1. So I can also write it as an equal to 3n plus 1. Now, if you remember the nth term can be the first term, second term, third term, 100th term, any term of the AP. We have a general formula which is an equal to a plus n minus 1 into d, where a is the first term, the first number, d is the common difference, and n is whatever nth term we want to find, whether it's the 5th term, the 13th term. So now, if I already know an expression that the nth term of this AP will be some expression like 3n plus 1. This n, if I substitute some value of n, that will give me the value of that nth term. So if I want to find, suppose the first question is asking, find the first 3 terms of the AP. So the first term of the AP, if I plug in n equals to 1, that's the meaning of first term. So if I put n equal to 1 in this expression, so I will get a1 or just a, same thing. That is equal to 3 into 1 plus 1. That is 3 plus 1, that is 4. Now, before I move ahead to find the second and third term, if I just quickly look at the options, only the last option starts with 4. I want the AP to start with 4. 4 is the first term. So option D has to be correct. So the first three terms of the AP are 4, 7 and 10. If I plug in n equals to 2 and n equals to 3, I will find the second and third terms are definitely 7 and 10. Then they're asking us what is the common difference of the AP. Now since I already know the first three terms of the AP, if I take the second minus the first number, that is 7 minus 4 and that is 3, this will be the common difference. So the difference is 3. Even the third minus the second, 10 minus 7 is the same, it is 3. Okay, then the third one is which of the following is not a term of this AP. Either I can just list the terms of the AP because the numbers are smaller. The AP starts from 4, 7, 10, then the next numbers are 13, 16, 19, 22 and so on. And somewhere I will find that three of these options, the numbers in the options are terms of the AP and one of them is not. But if I want to solve it in another way, I already have an expression for the nth term of an AP, which is 3n plus 1. So suppose if I take the first number 25, let's say that the nth term is 25, and then if I am able to find that for some natural number n, I will get the nth term as 25, then I will say 25 is a term of the AP. And the an expression, the nth term expression is 3n plus 1. So if I plug in 3n plus 1 equal to 25, I get 3n equals to 24, and that means n equal to 8. That means the eighth term of the AP, is 25. So 25 is part of the AP. I am trying to find which is not a part of the AP. So if I take the second option as 27, let the nth term be 27, then I get 3n plus 1 equals to 27, 3n equals to 26. So n equal to 26 by 3, which is some sort of a fraction and decimal. It's not a natural number. So I cannot have something like 26 by third, or if I write it as a mixed fraction, this will be 8 2/3. There is no 8 2/3 term. It can either have an 8th term or a 9th term. So there is no meaning to having a 8 2/3 term. So that means that 27 was actually never a part of the AP. If it was, the n value would have been a natural number. So the correct option here is option B. Which of the following is not a term? 27 is not a term of the AP. Then the last one is, what is the sum of the first 10 terms of this AP? Now I have a lot of information available to me, and I also know the sum of n terms formula. And the formula is Sn equal to n by 2 into 2a plus n minus 1 into d. I can just plug the values. Now this is also same as n by 2 into a plus l. These two formulas are the same because l is the last term or the nth term, which is same as a plus n minus 1 into d. Right. Now I need the sum of 10 terms. So n is equal to 10. S10, sum of 10 terms is 10 by 2 into, the first term we found was 4, and the 10th term, A10, if I plug the value of n equals to 10 in this expression, 3n plus 1, I get 3 into 10 plus 1, that is 30 plus 1, which is 31. So in the formula, 10 by 2 into 4 plus 31. So that is 10 by 2 into 35, which is 350 by 2, which is 175. So if I look at the option B, 175 is correct.